All right, so we are going to have a chart. Ooh, that's really small. That's okay. We are going to have pipe 1, let's call it P1, and pipe 2, we'll call it pipe sub 2. And then we'll fill this. I don't know if I gave myself enough room. We'll see. All right, so we have a speed or a rate at which these pipes are working at. I'm going to call it rate. I know I've called it speed in the past. You can call it speed. You can call it rate. Now, the rate that it works at times how long I let it to work for. So if I let a pipe keep flowing water for 16 hours, it's going to fill a certain number of pools. So in total, we are going to have how much work it can complete or how many pools it can fill, however you want to put it. I just put work most of the time. All right, so that is our table. It is work, so it's speed or rate times time equals work. I'm going to put an equal sign. Remember, this top row should be some sort of equation. You should be able to form, usually it's like distance equals rate times time, or it can be price per pound times pounds equals our total cost. This top row should make a thing. Now let's just fill in the information we know. So it says one pipe can fill a pool 1.25 times as fast as the second pipe. So I do not know how fast that second pipe works, but I do know pipe 1 works at 1.25 times its speed. And then that sentence it says when both pipes are open, they fill the pool in 5 hours. So that means in 5 hours, so they have 5 hours to work, they fill that pool. So pipe number 1 works at a rate of, so we have 5 hours. It's working at a rate of 1.25. So its amount of work done in 5 hours is going to be 5 times that 1.25x. So that is going to be 6.25x. Our pipe 2 has 5 hours. It's working at a rate of x. So the amount of work it's going to do is 5x. Yes?
So why would the time be 5 for both instead of one being like y and then 5 minus y? Because isn't one of them faster than
They're both working together, though. They both have 5 hours to work.
Okay.
We open them both up, and after 5 hours, we shut them both off. Doesn't matter how fast they're going, and the pool is full after 5 hours. So speaking of that, so this is the amount of work it can complete in 5 hours. So the amount of work pipe 1 does in 5 hours, 6.25, however fast it's going, plus the 5x is going to equal 1 pool being filled. So that's going to give us 11.25x equals 1, which we can come down to x just equals 1 over 11.25. Yes?
I didn't necessarily do it that way. I just did, I don't know if like this is like just a coincidence that I got it right or if it's not, but like I just added 1.25x plus x. So I multiplied 2.25x times 5 and I got 11.25.
Say that one more time. You multiplied what by?
I multiplied 2.25x times 5 and got 11.25.
Yeah, we did the same thing.
Okay.
Because we have 2 x's, basically, and we multiplied them by 5. You just added it together and multiplied by 5. You just kind of did a totals column, which is what we're coming up with here. All right, so we have x equals 1 over 11.25. But note this x goes into pipe 2, which is the slower one. So if pipe 2's rate is 1 or 11 over 25, so let's put that pipe 2's rate is going to equal 1 over 11.25.
Pipe 1 is 1.25 over 11.25?
Yes, if we're doing that rate. Yep. But we don't care about that. We just care about the second one because it says, what happens if I just use the slower pipe? And since the slower pipe's rate is 1 over 11.25, remember, rate as a fraction would be basically 1 task or 1 pool per hour. So that would be 11.25 hours. So that's 1 pool per 11.25 hours. It asks how long does it take to fill up 1 pool. That would just be 11.25 hours. This is a tough problem. So if you were sitting there thinking and you didn't quite get it, it makes sense. This is a tough problem, especially because rate, we're used to having fractions to begin with. This one didn't. This is a tough problem. All right, any questions on this problem, though?
Is he going to do the test? Or something similar?
Just assume the answer's always yes.
Are we good on that problem?
So it's like one pool per 11.25 hours.
Yep.
Yes.
Yep, that's how usually we have our rates. Unfortunately, this time we didn't know what the rates were, so we had to use X and stuff. But typically, if you know the rate, so if they would come up and say pipe 1 fills 1 pool in 30 minutes, you'd put the rate as being 1 over 30 right here. Because normally these rate problems have fractions in them. Even when it's 25 miles per hour, 25 miles per hour is a fraction. It's 25 miles over 1 hour. Our rates are always fractions unless we don't know them, and then we put X's in them. All right, I'm going to do the lesson first, and then I'll ask questions second, because I want to give people that don't have questions just time to start, because the homework is a bit longer. You also have a review guide that I handed out that is just to start. All right, we have till Friday to take the test, so Thursday is really when I care how far you get, so just start working on it. All right, circles. Circle is a set of all points in a plane that are equidistant. That's called a radius from a given point, which is our center of our circle. So the big takeaway from this definition here, and how you're going to use this, and a good key for some of these problems, is radius is just equal to the distance from the center to any point on the circle.
Like on the outside of the circle?
Yeah. That's the only thing that exists. There actually is no inside. That's just empty air. In fact, the center is kind of empty air. The only thing that actually exists is the circle. That's weird to say. But yeah, on the outside of the circle, if you want to put that. That's important to note because we know a distance formula. So if I give you a point on a circle and the center, the distance between those 2 points is your radius. And that can also get you the formula for your circle. Because continuing on, we have, since a circle is a set of all points that are equidistant from a given point, it's going to make sense that we're going to use a distance formula to actually come up with the formula for the circle. Because I want a formula that covers all of these points around the circle, but they're all the same distance from here. So every point has to maintain that same distance. Remember, your distance formula is distance equals the square root of one x value minus the other x value squared plus one y value minus the other y value squared. The only difference with a circle is rather than having x sub 1, x sub 2, we just have an xy value on the outside of the circle. Let's highlight that. And we also have a center value, which is h and k. So instead of x sub 2's and x sub 1's, we're using x's, h's, k's, and y's. And instead of distance, we are going to use, it's hard to see, there's an r right here. So rather than d, we're going to use r. So the formula to get from center to outside, our distance, would just be r equals the square root of x minus, and instead of x sub 1, we're going to use h. We're going to square that. Plus, instead of y sub 2, we're just going to use that y value, that's the point on the circle, minus that k value squared. This formula will now draw that circle if you plug it in your calculator, if you have the h and k value, because this satisfies every single point that's this distance away from here, that exact r. Now, that's one way to write the formula for a circle. The other way, and the more standard way, is to actually write r squared equals x minus h squared plus y minus k squared. This is the standard form for a circle. That is the standard form for a circle, but I just wanted to write it that top way because it is just a distance. And we know distance formula. If you know how to come up with your distance formula, and you know what a circle is, you can, on a test months from now, without knowing the formula for a circle, actually come up with it knowing the distance formula. I did rewrite it down here. So the equation for a circle with center of hk and the radius r, where r is bigger than 0, is exactly what we just wrote. I do want you to circle something, or at least put a little note by it. This is kind of important. A circle centered at the origin has the equation x squared plus y squared equals r squared. Now, these are the exact same formulas, except when it's centered at the origin, your h is 0 and your k is 0.
Wait, that's like the Pythagorean theorem.
It is pretty much the Pythagorean theorem. And Nick, if you think about it, it would be the Pythagorean theorem, because if it's centered at the origin, we just create a right triangle where it's just a squared plus b squared equals c squared. It all goes back to the Pythagorean theorem because it's distance. Distance is the Pythagorean theorem. But nice catch. All right, know that. So if your h and k are 0, you'll just have x squared plus y squared equals r squared. All right, let's go into some examples. These aren't so bad. These are sketch the graph of the equation. Now, the biggest mistake you're going to make, and people are going to do this, is you're going to say the center of this circle is -3, -2. If you wrote that, you're wrong. That's not right. That is not right. Because the formula actually says x minus h. So whatever this h value is, it should have a negative outside of it. So in fact, the center will be just 3, 2. The way I think about it is what x value actually makes this statement equal to 0. If I plug a 3 in there, 3 minus 3, that gives you a 0, so it's going to be 3. What y value gives me a 0 when I have y minus 2? That is going to be a positive 2. So our center is actually going to be 3, 2. Here's something else that's going to trip you up. Some people are going to say the radius is 4. But if we go back to the equation, r squared is actually on the other side. So 4 is not our radius. Instead, r squared, that 4 equals r squared. So I need to take the square root of both sides to give me my radius equaling 2. That's all the information you need to graph a circle. You need a center and you need its radius. Because now we just plot that center at 3, 2. So we go 3, 2. That's my center of 3, 2. And now we have a radius of 2. The easiest way to do your radius of 2 is just to go up 2. So we're going up 2 and plotting a point. We'll go left 2. We'll go down 2. We'll go right 2. And that's going to be a very perfectly drawn circle. No, that's perfect. Any questions on any steps that I did there? Like I said, I'm going to fly through this because you already did circles. So I go on the basis that you've seen this before. But if you haven't or you don't remember something, you need to stop me. Our next one. Yeah, Nick.
So the center is just always the last 2 numbers.
The last 2 numbers.
How did we find the center again?
We got the center from, our formula says h and k are buried into this x minus h, x minus, or y minus k. So h comes from right here, k comes from right here. So if we look here, my h is that 3, my k is that 2, that's my center, 3, 2.
Okay, and then do we always make it positive?
No, because we'll see then the next one is something different. Can someone tell me the center of the next one? Kate?
1 -2.
It would be 1 -2.
So it's opposite.
Yeah, it's opposite. I'm looking for what can I plug in y that makes this statement 0 and it'd be a -2. The other way you can do it is you can rewrite it in standard form. Well, kind of a version of standard form. So I have x minus 1 squared plus, and I would change this to y minus a -2 squared equals 9. However you want to remember this, our center is going to be 1 -2 because you do have to have those negative signs to be in standard form. So our center is that. Our r squared is going to equal 9. So that means r equals 3, or my radius equals 3. Center is 1 -2. My radius is 3. Remember to take the square root of the item on the right-hand side or the left-hand side, the number. Yeah.
Do you always go by twos for like from the center to form the circle? Like the radius.
My radius is 3 in this one.
Alright, good.
Yep, my radius is 3 in this one. I was afraid that I picked both with 2 and then everyone thinks the radius is always 2. No, this one's going to be 3. Whew, you got me. All right, so our center is 1 -2. So that's my 1 -2. This time our radius is 3, so I'm going to go up 3. So my radius is 3 units, so I'm going to go up 3, left 3, down 3, right 3, and we have another perfectly drawn circle. Not on here, it isn't, because there's no friction.
Oh, okay.
Friction makes circles a little easier to draw.
I have to like turn my paper because I'll be like in this.
All right, questions on those two? Nick, you're good?
Yes.
Juan, you're good with it not being 2 every time? Okay, good. All right. Now we're going to step it up a bit. It says write the standard equation for this circle. Remember, standard form. So standard form of of a circle is going to be r squared equals x minus h squared plus y minus k squared. Well, h and k are pretty easy because they already gave us our center value. So if we just look at that center value, that -3 is going to be my h. That 5 is going to be my k. So let's put that underneath. So our h is going to equal a -3. Our k is going to equal a 5. The only thing you really have to do in this one is actually to find our radius. So we just need to find our radius or our r. I'm going to find my radius down here because I'm going to write my formula here. It just keeps it a little neat. Yeah. You sure?
Yeah. Wait. No.
Okay, yeah.
I got it.
Okay, I haven't actually done anything yet. I just
I know,
put the
I
negative.
was confused about the values because I was like, wait a minute, wouldn't that make it?
It's going to when I plug it back in. It's going to make it positive. Yes, yes. All right, so I'm going to do my radius down here. You can put it wherever you want. So I'm looking for my radius here, but I'm going to remind myself of something. Our radius, from what we put on the other side, is just that distance. It's the distance from the center to the outside of the circle. So our radius is just that distance, and maybe I'll highlight that with purple. It is that distance from point 1,8 to the center, -3, 5. So my radius is that distance. So radius is just a distance from center to point. And in this case, our r is going to equal the square root of subtracting our x values. We're going to have 1 minus a -3 squared. 1 minus a -3 squared plus our y value subtracted. So I'm going to do 8 minus 5. I'm going to square that. That's going to give me r equals the square root of 1 minus a -3 is a positive 4. 4 squared is 16. Plus 8 minus 5 is 3. 3 squared is 9. Equals the square root of 25 is going to equal 5. So I have h equals -3, k equals 5, and I also have r equals 5 as well. The only work I had to do was calculate r. All right, the h and k was given to me in this problem. All right, now we just plug in that information. So we plug a 5 in for r, so we have 5 squared equals x minus, remember h is a negative 3, so it's minus a negative 3 squared plus y minus 5 squared. Simplifying this, we're going to come up with 25 equals, and we're going to change this to x plus 3 squared plus y minus 5 squared. And Luke, I think you're okay with that 3 now, right?
Yeah.
So our radius is just the distance from the center to a point that's given to you. That is what we needed to calculate. And we just used the distance formula. X sub 2 minus x sub 1 squared plus x, or y sub 2 minus y sub 1 squared. Questions? Could you repeat this? Possibly? I like it. Like the complete optimism. 50-50. Jasia.
Would you not plug in the 1 or the 8 for the x and y?
I would not plug in the 1 or the 8. If you'd plug in the 1 and the 8, you'd actually come up with 25 equals 25. Yeah, the 1, 8 is actually a solution to this.
That's true. I did think it was.
Oh, yeah, I know. Unless you made a mistake, it should come out that way. Yeah, do not plug it in because our standard form should have x's and y's. Otherwise, you tell me 25 equals 25, and I'm like, good for you, Jossie. I'll just put a little yup. All right, other questions on this? Good thinking, though. All right, the last thing we're going to talk about is completing the square. And while we're completing the square is look at our formula. We have x plus 3 squared plus y minus 5 squared. In standard form, you do have to have a binomial squared plus a binomial squared. The whole point of completing the square is so you can write something as a binomial squared. So in this case, the rule for completing the square of, say I give you x squared plus bx, and I tell you to complete the square. What you're going to tack on to that is b divided by 2 squared. And the reason why you do that is, I don't have it here, but we're going to put it on there. X squared plus bx plus b divided by 2 squared actually equals x plus b divided by 2 squared. It is a trinomial that we can turn into a binomial squared. That's the whole point of completing the square. It's not hard. Don't fight it. It's just b divided by 2 squared. That's your big thing in these. Now, let's see when we're going to be applying these. Well, we're going to apply them to something like this second problem. We're going to do the first two, but I'm going to show you how it deals with circles. If I give you x squared plus 6x plus y squared minus 5y equals negative 1 over 4, and I tell you to write it in standard form, remember, standard form is a binomial squared plus a binomial squared equals something. There is no way for this to happen unless I actually complete the squares. All right, so let's do small step at a time. We'll complete the square for x squared plus 6x. Well, to complete that, we're just going to take that b term, which is 6. We're going to divide it by 2, and we are going to square it. Well, simplifying just a little bit, we're going to have x squared plus 6x plus 3 squared. I'm not going to actually do the 9. These two things are equal. The reason why we're doing this is because now I can write this as a binomial. I can write this as x plus, and we're just going to take the 3 portion of it because the squared goes on the outside. So x squared plus 6x plus 3 squared does equal x plus 3 squared. The 9 doesn't go here, the 3 goes here because the squared goes on the outside. If you do the math, it works out. All right, completing the square of 5x squared minus 5x. Well, once again, we're going to take that b value, that negative 5, divide it by 2, and we're going to put a square up there. And the whole reason for this is so we can say this equals x. Because we have a negative sign here, we also have a negative sign here, we are going to put a negative sign here. And it'll be minus 5 over 2, so we drop that 5 over 2 there, squared. We drop the negative along with it. And that is now a trinomial turned into a binomial squared. And here's where it really comes in, is this problem right here like I talked about before. What we want to do is we want to turn that x squared plus 6x into a binomial squared, which is what we just did right above it. But your steps, how I usually do these is I'm doing something like x squared plus 6x plus something. I'll fill in that something in just a second. And I'll do plus y squared minus 5y plus something to complete the square is going to equal negative 1/4. Now, you're not allowed to just add something to one side. It's kind of like if you're lifting weights and someone puts 50 pounds on one side of your barbell. It's going to be bad. You're going to put 50 pounds on both sides. So if I add something on one side, we're going to add both of those things to this side. So plus whatever blank I had, plus that other blank. Now let's fill in those blanks. We are just completing the square. So my b is 6, just like the one above that they match. So we are going to plug in 6 divided by 2 squared. And as soon as I plug in that space, I'm going to put it on the other side, 6 divided by 2 squared. Now we're going to deal with the y squared minus 5y. Well, our b is negative 5, so we'll do negative 5 divided by 2 squared. As soon as I do it to one side, I do it to the other side. Negative 5 divided by 2 squared. Now we have a balanced equation, but now I can write it as binomial squareds. Because we are going to, let's take care of this part first. Let me highlight it kind of. So we're going to rewrite this part first. Well, that's just going to be x plus that 6 divided by 2, or 3 squared, plus, let's go ahead and do the y's. That's going to become y minus 5 over 2, so I take the negative along with it, squared. And that's going to equal, well, negative 1 over 4, plus, I'm going to say this is 36 over 4. I didn't simplify it because I know the common denominator is 4, so why not just leave the denominator there? Plus, well, negative 5 squared is 25. 2 squared is 4, so it's 25 over 4. Well, that is just going to equal 35 plus 25, which would be 60 divided by 4. So our finished equation would be x plus 3 squared plus y minus 5 over 2 squared equals, well, 60 divided by 4 is 15. I didn't ask for this in this problem, but I'm going to put it down there just because I have a little bit of room. What's the center of this circle? Be careful. Nick?
It's negative 3. 5 over 2.
Yep. 5 over 2. Can someone give me the radius? I don't need a decimal. Yes. Square root of 15. So if I gave you that and I asked for the center or the radius, this would be the way to get the center or the radius also, putting it in standard form. Questions? I know we went through it really quick. It's actually a lot of material all at once. The homework, there's only a couple challenging ones. Otherwise, they're basically like the examples we did in class. All right, that being said, what questions do we have on the homework then? If you don't have any questions on the homework, you can go ahead and start the homework for tonight. Yeah.
Oh, there's a question about 65.
65. Do you have a specific question, I guess, on 65?
Not really.
Did your answer just not match the answer key?
Yeah, so you add the...
Shh. I know you can work, but you got to work silently while we're doing this. That is way too small. Okay, really, really quick. we need an x-intercept, and we need a y-intercept. So to get x, I'll set y equal to 0. So if y is 0, I really only have negative 1/2 x equals 400. Multiply both sides by a negative 2 to come up with x equals negative 800. And that would be the point negative 800, 0, because our y is 0. And then to get the y-intercept, we're just going to let x equal 0. So we'd have 2 over 3y equals 400. I would just multiply both sides by the reciprocal, which would be 3 over 2. Okay?
Yeah.
Or you can multiply both sides by 3 and then divide by 2 if you wanted to do that as well.
Yeah. Okay, that makes sense.
Okay? Other questions? Yeah, one.
The second word problem.
The second word problem. Not the first one?
You can do both if you want.
I don't want to do both. It's just the first one was the hard one. That was the challenging
What
one.
was the first one?
So our second one, you have questions on both of them?
Yeah.
Do you have specific questions?
No, I didn't know how to like.
Okay. So we'll go through the second one. I think the second one is one I can pick several of them on the test because it is just a normal speed problem or work problem. It says Billy can paint an entire house in 12 hours. That means his rate is 1 over 12. One house per 12 hours. That's where I came up with this 1 over 12. Bob can paint a house in 8 hours. So that's one house over 8 hours. That's why under speed I have 1/8 for Bob. They're working together. How long does it take to paint 2 houses? So the time we don't know, but they're the same. So Billy's going to work certain hours, and Bob's going to work the same amount of hours. They're going to work together until they are done. So the total amount of work Billy can do is 1/12 times x, however long they work. Bob can do 1/8 times x. I'll give him amount of work. Well, they said they're painting 2 houses. So the amount of work Billy can do is 1/12 times x, plus the amount of work Bob can do, which is 1/8 times x, equals 2 houses, because they want to paint 2 houses. And then we just solve that equation. And we end up with x equals 48 over 5, which equals 9.6 hours, or 9 hours and 36 minutes. For the one above it, Jason drove his rig on Interstate 10 from San Antonio to El Paso. At the halfway point, he noticed that he had been averaging 80 miles per hour, while his company requires his average speed to be 60 miles per hour. So all the information they gave us there is he's going from San Antonio to El Paso. So, and he stops halfway. So I just said San Antonio to halfway, and halfway to El Paso. And then they also give us total, because they said the total average speed was 60 miles per hour. Well, the distance is the same to the halfway point as is the halfway to the end point, which means our total distance would be 2x. They did say from San Antonio to the halfway point, he noticed he's going 80 miles per hour. So I just put 80 miles per hour there. We don't know how long it took or what his speed was going the rest of the way. That's what we're looking for. So I just put a y in its place. But it did say its total needed to be 60 miles per hour. So we put 60 miles per hour. Well, time, I'm just going to use this x and 80. I'm not going to come up with a brand new variable. So since distance equals rate times time, you need to know how to manipulate that formula. So distance equals rate times time. If you divide both sides by rate, you're going to see time equals distance over rate, which in this case was x over 80. The distance divided by rate in the next one is x over y. Our total time would be these two things added up. And then you just solve. So you have two variables. Remember, you should be looking at the answer key so you can have more specific questions, because if you don't have specific questions, I just can give you generic type answers. The better the questions, the better the answer I can give. Other questions? Yes?
Just something on the review. Number 13, I think it's a typo.
Yeah, number 13 should be 45 and 40.
Okay.
Yeah, if you look at the review, I didn't expect anyone to get to number 30 because you should be doing the homework. But it should be 40 and 45. I'm sorry, 45 and 40 in that order.
40 by 40.
It should be 45 and 40 in that order. Because it said he went slower and all of a sudden the average was faster. Yeah. So number 13 should be 45 and 40. Other questions from the homework?
Older than like yesterday's or today.
Yesterday's. Okay. Yeah.
Sorry, can I ask you, like, when you turn around a question about the homework from the weekend, because I wasn't here in class yesterday?
Yeah.